working with an air vehicle have been proved that they efficiently break up ice on the water. There are two situations where the air cushion technology can be used. The first one, at low pressure, the introduction of an air cavity under the ice cover causes the cover to fail under its own weight. Why? The second one, at higher speed, is by generating a wave in the ice cover behind the vehicle to break the ice. The circumferential cracks in the ice are caused by the bonding moment from the pressure of the air cushion. This happens when there is enough pressure of air cushion to depress the water and force air below the feet. The first one is to measure the minimum cushion size required to break a given thickness of ice based on given cushion pressure. The second one is to measure the minimum cushion pressure required to break a given thickness of ice based on given size of air cushion.
Now I will explain about the mathematical model of this project. First, to break an ice, the bending moment, which is m, must reach a certain point to produce crack in ice. At distance x, the maximum bending moment is given by this equation. The relationship between the tensile strength, which is sigma, and the bending moment is the second equation. By equating both equations and solve for sigma, we got the third equation. From the above equation, we solve for r and we got the fourth equation. From this equation, now we can solve for the problem 1. From the fourth equation, brings all the term to the left and we have the fifth equation. The fifth equation we can use to solve for the problem 2.
In problem 1, the cushion size required to break the given thickness of ice can be solved by using the formula of R. Through R, we can obtain the graph. Here, as we can see from the graph, the cushion size does not produce any value when it reaches the line of P equal to 0.4 H, which means that after P is greater than 0.4 H, the air cavity does not extend any more distance, which is it is illogical, and it's presumable that the ice would be ready to break, then extend to a larger air cavity. For the problem 2, the cushion pressure needed to break the given thickness of ice can be calculated by using this equation. So, after applying the Newton method, the result obtained as seen by this graph. As we can see, there's the line of P equal to 0.4 H, just like in the problem 1. But unlike in the problem 1, this time, in order to yield the result of P, the pressure must be greater than 0.4 H.
Conclusion, this study examines the possible ways to increase the effectiveness of ice breaking process, and the air cushion vehicle is one of the effective methods to break the ice on the water. The reason why ice breaking is important for the country, especially at the cold weather country, are to satisfy reasonable demands of commerce and control the potential of flood. For the problem number 1, the cushion size needed to break the given thickness of ice is valid if the pressure is more than 0.4 H. It is because a cavity cannot extend to larger distance or the bonding moment is over the maximum value. And in problem number 2, the air cushion pressure needed to break the given thickness of ice and size of air cushion only yield the result when the pressure is more than 0.4 H2. At the end of this study, we found some recommendations that can increase the effectiveness of ice breaking process. Number 1, low speed of air cushion ice breaking. Number 2, the influence of hull shapes. Lastly, the most important thing, we have to try develop better ice breaking effectiveness measures and investigate new techniques for better defining the river ice environment. This effort must be supported by the community, intellectual sites, and government itself.